In this video, we're going to do a quick overview of how to deal with function transformations. And we'll be using this general form for transformations of equations. And note that all of our variables, a, b, c, and d, are real positive numbers. So let's first start with horizontal transformations. So we're zeroing in just on the transformations that appear in parentheses, so the bx plus c. And let's take a quick look at what b and c will tell us, what type of transformation that will give. So c, you will shift horizontally, right or left. And b, you'll stretch or compress horizontally. And note that if you have a negative b, the negative causes your function or your graph to reflect over the y-axis. So that's a horizontal reflection. Okay, a couple of tips for horizontal transformations. First, these are only going to affect your x coordinates. So that's something that's really important to keep in mind. Regardless of what method you're using for transforming, anything you see within the parentheses, that's going to be affecting only your x coordinates. Okay, and our other tip is to use solving order when dealing with horizontal transformations. So we'll get into this a little bit more when we look at some examples. If you only have one, the order is really not important because you just have one. But if you have multiple, you want to think, okay, you're going to handle these in the order that you would if you were to solve an equation. So if you were to take your transformations and set them equal to 0, which would you do first? And let's go ahead and look at some examples. So first we're going to look at some shifts. We'll look both at y equals f of x minus 6 and y equals f of x plus 6. So we'll see how these are related. All right, so let's start with f of x minus 6. And solving order can help here too. So what I meant by that is if you were to take your transformations and set it equal to 0, that tells you you're adding 6 when you solve. So you should be adding 6 to all of your x coordinates. And we can do this just visually on the graph. So take each of the main points and shift each point to the right 6. So we'll start here and we'll go right 1, 2, 3, 4, 5, 6. Okay, next, moving right 6. And you just go point by point, shifting each to the right 6 units, and then you can sketch in your graph. Okay, great. So that blue function is our new graph, f of x minus 6. Okay, so now let's look at y equals f of x plus 6. So we know we're going to do this as our only transformation. We're not really concerned about the order, but solving order still helps us think, okay, for this transformation, we're shifting horizontally left 6, or we're subtracting 6 from all of our original x coordinates. And keep in mind the purple graph is our original graph, f of x. So take each of those points and move them to the left 6. There's our first one, our second, our third, our fourth, and our fifth. And then we can sketch in our final graph. So this is f of x plus 6. Okay, so now that we have some shift practice, let's go ahead and look at stretches and compressions. So we're going to take our original purple graph, f of x, and we're going to apply these stretches or compressions. So let's first start with y equals f of 2x. And the solving thought helps here too, because you just take your transformation that's within the parentheses and you set it equal to 0 to help you identify what is this transformation actually doing. So to solve for x, all we would need to do is divide both sides by 2. So we see this is actually a compression. It's shrinking our graph is another way to say it in the horizontal direction. Okay, so we take all of our x coordinates and we divide them by 2. Note that the y coordinates are not changing here. Okay, so we take our point at -4, 0, divide the x by 2. Take our point at -3, 3, we divide that -3 by 2, and we get a point at -1.5. The y coordinate stays the same, still 3. Okay, we're taking that middle point now. Its x is -2. If we divide that by 2, it becomes a -1. Our fourth point is at -1, 3. So if you divide that -1 by 2, you get -1/2. And finally, our last point, this furthest to the right, its x coordinate is 0. So 0 divided by 2, that point stays put. It does not change. So this is our new graph, y equals f of 2x. And notice that it does look shrunk in the horizontal direction or horizontally compressed. All right, so now let's look at this other graph. So this is still transforming the original purple graph. This time it's y equals f of 1/2 x. Okay, so use that solving order to help you know what are you doing to your x's, what is our horizontal transformation. And to solve this, you would either divide both sides by 1/2, or you may even think, well, it's just easier to multiply both sides by 2. Because whether you multiply by 2 or divide by 1/2, that's doing the same thing. So let's stick with the one that's a little bit easier for moving point purposes. We'll multiply, so it's multiplying times 2. Okay, so stick with that purple graph. We're taking our x's, we're multiplying them by 2, and our y's are staying the same. So moving from left to right on those purple points. So -4, 0 becomes -8, 0. -3, 3 becomes -6, 3. -2, 1 becomes -4, 1. -1, 3 becomes -2, 3. And 0, 0 stays the same. So you can see that this one is stretching out our original purple graph. And I know we are getting a little messy there, but hopefully you can still see. You could always move these to separate graphs. But you can see that our original purple graph has been horizontally stretched out. So this is what a horizontal stretch looks like. All right, so now that we have looked at shifts and stretches or compressions, let's move on. And we'll quickly look at what a reflection would look like. So this is if we took our graph f of x, our purple graph, and we reflected it horizontally. So when I see the negative sign, then the negative is your key. It's taking all of your x's and making them negative. So that's going to reflect horizontally or reflect over the y-axis. And so I remember that simply by drawing a quick grid and saying, okay, if I were to reflect a point horizontally, well, that would move it across the y-axis. Okay, and I move my pencil back and forth in a horizontal direction and say, okay, we're flipping over the y-axis. So again, that might help, that might not. All we're doing is we're taking our x's and we're changing the sign. All right, so starting with our leftmost point, -4, 0 becomes 4, 0. -3, 3 becomes 3, 3. Notice our y coordinates still are not changing. These are only horizontal transformations. They only affect the x. So -2, 1 becomes 2, 1, and -1, 3 becomes 1, 3. 0, 0 is on the axis, so it stays right there. And you can sketch in your graph. Finally, before we move on to our vertical transformations, let's look if we do have multiple horizontal transformations. And this is where that thought of solving order will really come in handy. So you see we have y equals f of 2x minus 4. So you can see that we are both shifting right and horizontally compressing. And so we need to know which one to do first because the order matters. So if you use your solving order trick and you just take your horizontal transformations, so what's within the parentheses, and you set it equal to 0, you just think about, okay, well, I'm going to do this in the order that I would solve for x. So we know we would first add 4 to both sides. So that tells us, and I'll make a note of this, so our horizontal transformations, first we're going to move right 4. Okay, and of course then you would have 2x equals 4. And then our second transformation, you would divide by 2 to isolate the x. So I'm just going to use shorthand here, divide by 2. All right, so we'll follow that order with each point. And in a later video, I'll go through, you can see we're just transforming on the graph here because we're dealing with a pretty decently easy graph. When you have more difficult graphs, you may want to use a table or at least plot intermediate points. So check out some of those later videos if you need help with that. All right, so let's start with our leftmost point again. We'll first move it right 4. So negative 4, 0 ends up at 0, 0, and then we divide by 2. So that point actually ends up here. All right, then we'll move our second point. So at negative 3, 3, we first move it right 4. And then so that's at 1, 3. And then we divide by 2. So we end up with a point 1/2, comma 3. All right, we take negative 2, 1 now. So remember, we're just affecting that x coordinate, that negative 2. We shift it right 4. So it's at 2, 1. And then we divide by 2. So it's at 1, 1. All right, fourth purple point. Let's move that one right 4. So we end up first, or as an intermediate, at 3, 3. And then you divide that x coordinate by 2, and you get 3/2, 3. And finally, we move the point that originally was at 0, 0. We move it right 4. So it's at 4, 0. And then we divide by 2. All right. So here's our graph. You can see that we've shifted this right 4, and we've compressed it by a factor of 2. All right, so now let's switch gears, and we will move on to vertical transformations. So here we're zeroing in on the part of the equation that is the vertical transformations. So namely, that's our A and our D. So A is going to stretch or compress our graph vertically, and D will be a shift either up or down. And do note that if we have a negative value for A, that does cause a reflection similarly to our horizontal reflection, but this time it will reflect vertically or over the x-axis. Okay, so our tips for our vertical transformations, first and foremost, vertical transformations only affect the y coordinates for your graph. Okay, so vertical y, those go together. And you're going to want to apply your transformations in PEMDAS order. So mostly that's going to be, you want to multiply or divide by what you see first, and then you'll add or subtract. And sometimes here I like to say what you see is what you do. You don't have to worry about the whole solving order bit because of how this equation is written. We're applying these to the function exactly as we see them. So let's look at some practice. First, we're going to look at shifts. So vertical shifts are up or down. So here we have our function f of x is in purple, and we want to find f of x plus 3. So all we need to do is take our graph and move it up 3. That's adding 3 to the y coordinates. All right, so here we go, one at a time. First point up 3, second point up 3, third point up 3, fourth point, fifth point. Easy enough. The x coordinates do not change in this example because the plus 3 simply affects the y coordinates. All right, so you can see that our graph, our m, has just shifted up by 3 units. Okay, so you see now we're going to look at a similar equation, but this time it has minus 3 to our original function f of x, so our purple graph. All right, so you probably have guessed, all we need to do is move each point down 3. The x's do not change for this example. So first point down 3, second point down 3, third point, fourth point, fifth point. You've got it. So now our green graph is y equals f of x, close parentheses, minus 3. All right, so vertical shifts are easy enough. Let's move on now to stretch and compression for vertical transformations. Okay, so you can see that here our stretch or compress appears right in front of that f of x. And we will first start by looking at y equals 3 times f of x. So all this is doing is taking our y coordinates and multiplying by 3. What you see is what you do. You're taking that function, you're multiplying the y's by 3. There's that understood multiplication dot between those. All right, so for our first point, our y coordinate's 0, so it just stays put on the axis there. Our next point is at negative 3, 3, so our y coordinate of 3 is multiplied by 3, and it becomes 9. So it stretches way up there. This is a stretch vertically. All right, our third point, multiply that y coordinate by 3, or vertically stretch by a factor of 3. Our fourth point, y of 3 becomes a y of 9. And finally, our point at 0, 0 stays the same. So this one is a vertical stretch. All right, now let's look at the next one, which you guessed is a compression. So we see that 1/3 out front. So we're going to take all of our y's and we're going to multiply them by 1/3 or compress or shrink them. So we'll do this in red. Okay, so remember the x's are not affected here, it's just the y's. So our y here is 0, so 1/3 times 0, it stays put. Our second point, negative 3, 3, that y coordinate shrinks down to 1 because 3 times 1/3 is 1. Third point, that y is a 1, so let's multiply it by a factor of 1/3. Shrinks down, and the fourth and the fifth point follow similarly. So you can see that this has been compressed vertically, or vertically shrunk. All right, now that we've looked at shifts and stretch and compression for vertical transformation, let's finish up just a little bit here. First, we'll start by looking at a vertical reflection. So you can tell this is a vertical reflection because the negative is out front. It's not with the x. So it's going to affect the y coordinates. All of our y's will change sign or become negative of themselves. And I'll draw a quick little diagram here. So if you have a point and you vertically reflect it, it moves down here. And so you can see that's a reflection over the x-axis. Okay, so let's just take each of our points. We're taking our y's and we're making them negative. So on the x-axis stays put, but the second point, the y flips down to negative 3. Our third point, the y becomes negative 1. Our x's are staying the same. A negative 3 and a 0. So you can see the m has just flipped upside down. Now it's a w in the third quadrant. And finally, let's look at multiple transformations, multiple vertical transformations. And so you notice that we're keeping in this video every example, we've kept them in isolation. Eventually, you're going to put all of them together. Eventually, you'll put them into specific functions, some of our parent functions. For right now, we've really tried to isolate them so that you can see how each works. And if you can do them separately, then you can put them together, and we'll talk about that right before we finish up. All right, so you can see we have 2 vertical transformations here, and you want to follow that PEMDAS order. What you see is what you do. And so it really often ends up you're reading from left to right, and so it feels more natural potentially. All right, so the first thing you're going to do, let's make a list. Vertically, we'll take our y's and we'll multiply by 1/3 because multiplication comes before addition. And the second thing you'll do to your points is add 1. So that'll move up 1. So you can put up 1 or you can put y plus 1, whatever is most helpful to you. Okay. So let's apply both of these to each point one at a time. So starting with our first point, our leftmost point, multiply that y by 1/3. Okay, 0 times 1/3 stays put, and then it moves up 1. Okay, so we take our second point, the y coordinate is 3. When you multiply that by 1/3, it becomes a 1, and then it shifts up 1. Our third point, when you multiply that y coordinate of 1 by 1/3, it becomes 1/3, and then you move up 1. So that's at 4/3 or 1 1/3. Okay, similarly, the fourth one acts like the second since they have the same y coordinate. 1/3 times 3 is just 1, and then shift up 1. And 0 times 1/3 for the fifth point is still 0, and move up 1. So you can see that this has definitely vertically compressed our image, and it shifted it up 1. All right, so as a quick summary before we finish up, this is the easy order of function transformations when they're all put together. This is how I like to do it. You don't have to do it in this order, but I think it just makes it run very smoothly. It eliminates a lot of the probability for error. So first, you should start with whatever your C transformation is, so your horizontal shift, then your horizontal stretch or compression, then move on to your vertical stretch or compression, and finish with your vertical shift up or down. Okay, so that incorporates the solving order for your horizontal transformations, and then your PEMDAS order for your vertical. So check out some of the later examples. I'll post some videos for both general form transformations and then many videos for transforming specific functions. And once you get a really good system for this, it becomes very, very easy. You can transform any function that someone throws at you.